Bismillahirrahmanirrahim. Assalamu alaikum. Dear student, today we will study the basic parts of the AC machine. Well, the AC machines are simple in construction. So we are having the typical AC machine, which is the induction motor, and here this is the rotor of the induction motor, and this is the stator of the induction motor. Okay, so here in case of the AC machines, the armature windings lies on the stator of the AC machines, while in the case of the DC machines, the armature windings lies on the rotor of the DC machines, whereas the excitation windings lies on the stator of the DC machine. Here this is the rotor, and this rotor will be inserted here. So when there is a rotating magnetic field in the case of the induction motor, when supply is applied to the stator part of the induction motor, voltage will be induced in the rotor, and according to the Lenz's law, it will start rotation. Okay, theoretically there are two types of the AC machine: asynchronous machine and the synchronous machine. So asynchronous machine is having some value of the slip. So what is slip? Slip is basically the difference between the rotating magnetic field and the rotor speed. So this is the difference between the speed of the rotating magnetic field, which lies on the stator, and the speed of the rotor. Okay, there are two types of the asynchronous machines on the basis of the rotor. One is this simple construction. This is the squirrel cage rotor, and the second is the slip ring rotor or the wound rotor. On the squirrel cage rotor, you can see here, these are the end rings. This one and this one, these are the end rings, whereas in the middle there are solid aluminum rods, or it might be the copper rods. Whereas in the case of the slip ring rotor, the windings lies on the rotor, and there are slip rings. So these are the slip rings, and basically this is a three-phase induction motor. So that's why we are having three slip rings on this rotor, and these are the carbon brushes sliding against these slip rings. Okay, in case of the wound rotor or the slip ring induction motor, we can connect external resistance in the rotor of this induction motor. By connecting the external resistance, the starting current can be reduced and the power factor of the induction motor can be improved. Okay, so these are the two rotors of the asynchronous machine, the squirrel cage rotor and the slip ring rotor. Now moving towards the synchronous machine, the stator is the same, while as you can see here, this is the rotor of the synchronous machine, this one, and you can see here that this is the salient pole rotor. So there are two types of the synchronous machine rotors. One is the salient pole rotor and one is the non-salient rotor of the synchronous machine. In case of the synchronous machine, you people know that the slip of the machine is equal to 0, whereas the rotor and the rotating magnetic field, which is rotating with synchronous speeds, are locked together, and we have to provide external DC excitations by means of carbon brushes. So here basically there are three slip rings, but the excitation is DC, so we will give positive and negative here. So here will be some DC excitation to produce the magnetic field. So similarly, we are having a transformer. The principle of transformer and induction motor is the same. In case of the transformer, secondaries are static, where in the case of the induction motor, this secondary is rotating. So when the secondary rotates, obviously there will be some windage losses in the induction motor. There are some various types of the single phase induction motor rotors, where this is the permanent magnet rotor, this is the solid core rotor, and this is the squirrel cage rotor. This is this is a machine here, and this is a big machine you can see here, and this is slip ring induction motor. So thank you.